So welcome everyone. This is the talk about a malware called Carbanak. So to make sure you guys are in the right room. For 30 minutes today, I'm going to be talking about my journey in exploring this malware that I thought was pretty cool. Before we get started with that, let me just share. So, yes, everyone can hear me okay? Okay, great. So my name is Hristo Asenov. I'm a system software engineer at Rackspace currently. This is more related to my previous employment, which was at a company called Circadence. And there, what they do is they design cybersecurity virtual environments for learning purposes. So if you think there was a talk earlier about Hack the Box, it's something similar to that, but it's like on a bigger scale. Like they'll build a whole network of a red team and blue team environments. So this is me. This is my Twitter. In case anybody wants to get in touch. And kind of related to what I was talking about Circadence previously. So Circadence, they have a lot of red team and blue teams. And the blue team, they call them missions. So they're cybersecurity missions. And they have things ranging from like doing spear phishing. Another one they had was on ransomware. Like we put like the WannaCry ransomware in a mission. And then we always are trying to look for new and exciting malware. So what we're looking for is for a mission that dealt with banking transactions. And more specifically, if anybody here is familiar, there's a protocol about banking communications, how transactions are transferred. And this is the protocol that we're looking at, the SWIFT protocol. And me and a couple of colleagues looked around, looked at different things. And one thing that kept popping up a lot was this malware called Carbanak. So some background on the actual malware itself. So it was, I think, the actual attack happened in 2015. So quite a while back this happened. However, the malware itself is pretty complex, and there hasn't been that much information about it out there. There's a couple of resources I found. So the first company that actually disclosed this was Kaspersky. And actually, I should mention that Carbanak itself, it's mostly, it has been found to be present in like the Eastern Europe area, including Asia, areas around there. So Kaspersky was really the first company to do an analysis on it. And then a little bit after that, so here's the link for Kaspersky in case anybody needs to go back to it. Now, by the way, this is going to be recorded so you guys can just look at the video later on. But this is really the first write-up that came out, and let me show you guys what that looks like. So they came out with a PDF that was more related to how the actual attack happened. They didn't really talk about the intricacies of the malware itself, how it works. On the inside, they talked about the communications protocol and what kind of artifacts to look for to see if you're infected. So, for instance, right here, when the infection itself happens, it installs a couple of files in certain folders. This is, by the way, this is all Windows. So this is all Windows-based malware. And so from that, after a person came out with a report, then a malware analyst from FireEye analyzed the actual binary, and he came out with a write-up that was extremely detailed and very useful. And so his report is here. So after that happened, the source code was actually found online. It was found in some pastebin somewhere. So it was a very unique situation where somebody analyzed the binary and then you have the source code afterwards. So another researcher from FireEye went through the source code and they compared notes and they kind of talked about it in this blog and then have a follow-up YouTube video as well. I thought that was really interesting. So if you see here, if you look at the blog, a lot of the stuff is a lot of like comments in the source code and things like that are in Russian. So it's a little helpful if you know Russian, but I mean, yeah, and I'll go through that later on. In this PowerPoint, we'll look at the actual UI. It's like in the Russian language. So in the fire report, from the fire report, I really wanted to get the environment working, and I kind of had a lot of struggles with that, actually getting it working and having it run in my system. So in this talk, that's kind of what I'm going to talk about, my journey from getting the actual source code dump and the binaries to actually getting it running in my system. And then hopefully you guys can benefit from that, and you can take my work and analyze it further, because there's a lot of interesting things that are happening in this malware, I think. And the other two resources are, so the first two resources are more technical. They're more about like the actual operation of the malware and everything else. The other two are more media. They kind of talk about the exploit itself and like what actually happened. So those are interesting to check out as well. Yeah, the actual malware itself, right? So it has two components. It's a remote access Trojan, meaning that it has, on the victim, it has a binary that's executing, and it's talking back to a command control server, same as Metasploit, right? So running Carbanak itself wasn't easy for me. I had to do a couple of changes in order to get it running. And I really wanted to have the source code and be able to compile that, because in our environment, we have a lot of times we need to make certain changes, and we need to tweak little things. If you don't have the source code, you can't do that, right? So we really wanted to be able to compile the source code itself. The bot itself, it's written in Win32 C++, and I really wanted to do that to get it compiled, but unfortunately I didn't have success with that. So I wasn't successful in actually compile the actual Win32 C++ code. What I ended up doing was the dump that contained the actual binary. I was able to figure out how that works and was able to get that running within my system. And what ended up happening was I I commented on some source code that wasn't compiling for me, and then when I actually ran it, it was giving me crashes that were related to dynamic pointers. If anyone's familiar with C++, they have something called smart pointers. So they have that now. That implementation, what it was actually doing was it was implementing smart pointers in the actual source code. So it was actually re-implementing smart pointers. And I think that was because the version of the Win32 that they were using didn't have smart pointers at that time. So they did some kind of a weird stuff where they re-implemented operators. So I mean, if anybody's more familiar, I'm not very familiar with C++. I haven't really used it. If anyone is familiar with C++, you can definitely give it a shot. I think I got pretty far as that, but I mean, the binary that was there worked, obviously, so there must be a way to compile it, and there must be a way for it to actually work. So once we have the binary, it was a little bit complicated figuring out what actually needs to happen in order for it to work. So there's the binary, and there's actually a separate executable, which you use the binary as input into that executable. So it's a configuration executable, and what it'll do is it'll rewrite the executable to plug in its own values in there. So it'll insert the IP of the CNC, things like that. So there's a CLI version, and there's a UI, a GUI version. What you need to do is I need to set it up right here. I need to set my IP address right here in a configuration file, and then if you can see at the top, let me use my laser pointer. So right here, I'm running build.exe. .exe is the input executable. Example.config is the configuration file, which is this. And bot_out is the output executable, which actually the bot_out is what I actually used for executing the actual binary, right? Like I said, it has a GUI, but it's not very good. The code of this is not especially good. Like you can tell that they did it really hastily. Like some functions are called a certain way, but they don't actually do what they're called. Or you can see that somebody called it one way, then it kind of changed the functionality a little bit inside. So it's a little bit weird in that sense. That's one of the ways that you can configure that binary, right? The one that executes in the box. Yeah, go ahead. That's a good question. So I essentially got it from the dump. What I did was there was somebody else that had a GitHub that made it. He just made a GitHub of all the different artifacts, and then I took those artifacts and I modified them. So if we look at the source code, so I think it's this thing, and they're actually right here. So this is actually executable, and where's the example that comes? Oh, here it is. So yeah, it's in Russian, so it's kind of hard to understand exactly what it says. can use like Google Translate or something. But I just, all I did was I figured out that the video host needs to is what is the address of the actual CNC, right? So some of these don't make much sense. Like video host, you wouldn't think that that's the CNC one, but you know it worked. Yeah, obfuscation, right? So the other thing I think that you need to change is the password, or at least you need to know what the password is, so that you can configure it after it's running. Yeah, so that's where I got those from. Yeah, so then when you're actually running it, what's also interesting is that when it's running, you can actually reconfigure it while it's running. So it sets up in Windows, I think it sets up a named pipe, and there's another program called Cmd. If you start that up, it'll set up a comm between that binary and between the two binaries, and you can essentially configure it that way. There's a little README about the commands, and also what's nice is that the Kaspersky guys, they provided information about all the different commands too. Yeah, so they have stuff like RDP, VPN, VNC session. They have a keylogger somewhere. Yeah, so that was the actual payload itself that's running on the actual victim. Now for the CNC, that's in C#. That's a C# application, and I was able to get that working with Visual Studio 2012. And I suggest, 2013, sorry, 2013. And I suggest you use that version if you were to do this. It's all the changes that I made are actually on that GitHub account, and I created a couple of videos going through how I actually made those changes, if anybody is interested in exploring that. But essentially what happens is that this GUI right here pops up. This is a server, back-connect server. This right here is a back-connect server, and you see a line right here for this is actual the victim binary. Have the IP addresses, and then you have all the different ways you can do socks, CNC, RDP. And the other interesting thing is right here I have Process Explorer at the top. Here's the server, and then you can see right here there's it's listening on port number 700, and this is, I think this is 800. So it's listening on 2 ports, the server. And you know, you see here we have established connection from the victim. Yes, yes it was. And actually that Kaspersky paper has some information about how it was encrypted. Another thing I need to actually get it to work, and thank you for asking that question because I forgot about that. Another thing I need to get it to work was after you run that configuration executable, there's 2 files that get dumped out of that, two keys, and you need to take those, you need to put those on the server, because otherwise it's an encrypted connection, so it needs those in there. Yeah. But I wouldn't imagine it would be too hard to figure out what the communication is. Especially like once you have this, once I was able to modify the server, it was very easy. Like you can just set breakpoints of the server and you can see exactly what's going on. You can see what commands are going through, what actual, what it's sending back and stuff like that. So it's really easy to figure out once you have that. I don't think they were doing that. I think I only needed to do that for my specific use case. I think I would point you back to the Kaspersky paper because it has a little mention of that. I don't have knowledge about how this malware was running on the actual ATM software. I have no idea. I was just able to get it running for my own system, but there's some information here in Kaspersky about the actual certificates and what they were doing with them. So yeah. So we had the 700 port open and we have the 800 port open, right? So there's another command you need to run in order to actually control this, and it's called Cmd Manager, and it's actually another command that sits and communicates with server. And once it establishes a connection, right here, you're able to do file transfer. So I was able to do file transfer right here, and I was able to execute commands. So it's exactly like a shell, exactly like Metasploit. It's just it's written in C#. So and there you have a bunch of different things you can do on the actual victim itself. A little bit hard to see, but this is RDP here, and then you can start socks here. You can close RDP and other stuff. A lot of this stuff I didn't actually play around with it because you would kind of like need some time in order to figure out what each button exactly what it does. Because like I said, sometimes the button don't actually correspond to the action itself because it's a weird sort of project. We've done similar stuff like this at Circadians where we had Metasploit running and we needed to automate it. So we used Metasploit has this remote procedure called protocol, RPC protocol. You can start out MSF RPC. And we're using that to essentially automate Metasploit in our project. And I wanted to use something like that for Carbanak as well. So what I did was I went and I looked through Cmd Manager, that program that I just showed. I went and looked through the communications protocol and just to see how it's actually controlling the CNC, and I was able to just do a little very, very quick program in Python that will kind of duplicate that behavior. So like you can see here, I can get the back connect here. This is the back connect from the actual box. This is my IP. Yeah, and these are the ports that are open. I didn't have much time to do much further than that, but maybe I will go back and try to actually get a better version working. Yeah, so with that, I just want to say that I thought it was very interesting binary, especially on the victim side, like what the victim binary is doing. But I think also from from just the technological perspective, how the actual Carbanak malware works is also interesting as well. So what I was sure that it was doing privilege escalation, because when I would see the process itself, it would run with a system. So it was running a system, and it's doing something where it's installing itself as a service, and it's running a system. It's very typical of Windows Windows malware to do. There's actually something that I would like to go back to. Is so the FireEye guys did a presentation, and this is the list that they have for the exploits that were being used. They're nothing like 0 days and nothing too complex. Some of the stuff they actually stole from other projects, like they stole it from Metasploit, and I think they stole one from Cobalt Strike as well. But it would be interesting to look at that. Yeah, so I have you can get my videos from my Twitter. Yeah, I just want to say thanks to my colleagues, Todd, Mario, and William Rosado. Yeah, so with that, I'll open up to questions if anyone has any. Go ahead. Yes, I believe so, because the binary that's executed on the victim itself, it was looking for certain processes that are popular for banking transactions in those countries. So there was something similar to what was the program? There's like a little program, Zenmo, what's it called? Yeah, like in the movies. Yeah, so if you go back to this video, to this resource right here, I think it's this one. There's a podcast that talks about exactly that stuff. So yeah, yeah, yeah. I was just listening out on my way here, and it's very interesting. Sure. Uh, Yeah, it's actually I can show you right here. So if you look at this is the actual victim here, and this is the CNC here that's running. I have it paused right now. What I would suggest is if you want to do this, you want to make sure that you have your network adapter set to host only. You want to make sure you're doing that, right? Just can't stress that enough. But yeah, that's what I was doing. I had this is my victim and this is my CNC here. So does that answer your question? Yes, I was, and I was able to find that file actually. That file that they were talking about, I found that every single time. So that's a very good indicator of compromise. On what? Yeah. Well, I think my time is up. Yeah. Anybody else have any questions? I'm sorry. Answer everybody's questions. Okay. Thank you very much, guys. Appreciate it.